Hello, ladies and gentlemen, and what I would like to do just now to clean up our work a little bit. A couple of days ago, we worked on 2.3, the sine and cosine ratio, and this is like one of the very first days that we started on this. This might have been even the first sheet that we looked at. So go back and find that. Pause the video now. Find 2.3, the sine and cosine ratio. We actually did this. Mine is blank at the front. We did, if you take a look, we actually went through it. And I went through it with both groups. There was a video on it. And then we continued and we did this. We did finding the side. And then we did this. We found using an angle. And then we ran out of time. Or actually, the truth of the matter is I wanted to give you some practice. So I had you go off and do some practice. And we never finished example 5 and we never finished example 6. I'd like to do those now just so that you have a complete package from your notes so that you know what's going on. So here we go. We're going to look at some word problems, and that's what we're going to start really moving forward with as soon as we finish this, is more word problems. We're not always going to give you the diagram. So these next two examples give you the diagram and the words, and you have to figure the two out. What we're going to do after this, once this is done, is we're going to start doing questions that don't give you the diagram at all, and you're going to have to create the diagram. So, example 5, a ladder on a wall. So here's our ladder, here's our wall. A 6-meter ladder. So that's telling you something about the ladder. This ladder right here is going to be 6 meters long. Now, notice that it's a 90 degree between the wall and the ground. So we're going to assume 90 degrees between walls and grounds. We're going to assume 90 degrees between trees and ground, 90 degrees between poles and people and ground. Otherwise, if it's not 90 degrees, we expect them to fall down, like the Leaning Tower of Pisa, which is slowly falling down. So what we have here is a 6-meter ladder that's placed on a brick wall. The angle between the floor and the ladder. One of the problems with word problems is you have to read. You really do, and you have to slow it down and figure things out. Floor and the ladder. So here's the floor, I called it ground. The floor and the ladder is 29 degrees. So that's this angle right here. So that's the angle between the floor and the ladder. The only other angle with the ladder that we can talk about here is the angle of the ladder with the wall. So, and that's not what we're talking about. We're talking about this one. So the question is, how far is the foot? Now the foot is what we call the bottom of the ladder. I don't know why we call it the foot and we don't call it the bottom. And the top, for some reason, is called the top, not the head. So again, that's completely... that blows my mind. But in all of these questions, we talk about a foot of a ladder and a top of the ladder. Go figure. So there's the foot. And we talk about a base of the wall. We don't talk about the bottom of the wall for some strange reason. We always talk about a base of a wall. So how far is the foot? Here's the foot of the ladder. Is it from the base of the wall? So in other words, the question that they're looking for is, what's this distance? Okay, and they gave you the diagram. Now, in the next questions that we do, they won't give you the diagram, so you'll actually have to do something like this. You'll have to draw a wall, you'll have to draw a floor, you'll have to draw a ladder. You would do 6 meters for the ladder. You would call this your wall. You'd call this your floor. You'd make it 90, and you would say that this is 29 degrees. And that's how my diagram would look compared to theirs. And I actually think theirs is more complicated to try to figure it out. This is the base of your, or the foot of your ladder. This is the base of the wall. So what they're really after is this distance. So looking at this, you can go to town on it. That's your 90, so that's your hypotenuse. This is the angle, so that's opposite. I know nothing about the opposite. This is my adjacent, it's x. So the question is, what do I have and what do I want? I have an angle, I have a hypotenuse, I have an adjacent. Which trig ratio uses adjacent and hypotenuse? Cosine. So cosine of 29 equals x over 6. Hey, that's one of the easier ones where the unknown is in the top. By the way, the proper name for top is numerator. Okay, so it's in the numerator. I don't do anything different. I still make it a fraction equals a fraction. I put it over top of 1. I still cross multiply. So 6 times cos of 29 equals 1 times x. But this is so cool because x is isolated. What does that mean, isolated? Sean, what does it mean to be isolated? All by its little lonesome. Which means we can now do 29 cosine times 6, and we get x equals approximately 5.3. They didn't tell me what to round to, so it's up to me. So approximately 5.3 meters. Isn't that grand? That's a great question. That's a wonderful question. I have 5 minutes, and instead of doing the next example, I want to look at this example, but from a different point of view. I want you to think with me for a minute. I'm looking for a piece of paper. Let's take that exact same question. Don't write this down. Let's just stop. Let's just have a chat session. Let's take this exact same question. Let's say this was 29. Let's say this is 6. Let's say this is 90. And let's say we want to get the floor. Okay, now, all of you, we solved this just a minute ago using cosine, didn't we? I'm about to blow your minds. I'm going to solve it using a different trig ratio. Look how I do it. This angle up here is going to be, I'm going to call it A because nothing else is called A, so I might as well call it A. Angle A is going to equal 180 minus 90 minus 29. Which means that that angle up there is going to be 61 degrees. Does everyone agree with me? That's from angle sum of a triangle theorem. The insides of the triangle have to add up to 180 degrees. If you remind me after break, I'll prove that to you. Right now, everyone's just told it to you. I'll actually prove it. Okay, so that's got to be 61 degrees. So if I use this angle, this is now my opposite. This is now my hypotenuse, or still my hypotenuse. I can use sine of 61 equals x over 6. In this case, my unknown is still in the numerator. I change them both to fractions. I do cross multiply. 6 times sine of 61 equals x. Use my calculator, 61 sine times 6, and I get an answer of approximately 5.2 meters. The answer is off a little bit because of rounding. Look at how much that was a 4 and a 7. That was really close to being a 5, which would have made it a 3, right? Really close. They are considered the same answer, just done a different way. So isn't that interesting? I can do this one with the cosine using this angle, but since I know that I can find this angle as well, I could choose to do it with sine if I find the other angle first. In some questions, that'll be helpful. Just a little hint. We're going to stop here and we'll be back in a few moments.